So, welcome to the video lecture series on principles of compiler design. In today's video lecture, we will be learning about SLR parsing. SLR parsing is a bottom-up parsing technique. So, we have taken this grammar S tends to LA, L tends to BL, and L tends to D. Now, since this is called as a grammar now, the first step for SLR parsing is called as we have to construct an augmented grammar. What is meant by augmented grammar? Now, you take up what is the starting symbol in this grammar. S is called as a starting symbol. So, to construct an augmented grammar, you have to push the starting symbol S on the right side and introduce S dash symbol on the left side. Okay, that's what it has been done. So, S dash tends to dot S. So, whenever you construct an augmented grammar, you have to place a dot before every production which takes place on the right side. So, then since a dot is before S, okay, now we have to find the closure operation for S. What is meant by closure operation? That means when a dot is before a non-terminal, you have to introduce all the productions for the corresponding non-terminal. Now, in this case, dot is before S, so you have to introduce all the productions of S. Now, that's what the second step says. So, S production, we have S tends to LA. So, again, I place a dot before it. Now, again, a dot is before a non-terminal called as L. Now you have to find the closure operation for L. Okay, that means introduce all the productions of L. So L, you have two productions for L. L is called as L tends to BL and L tends to D. Now that's what has been done. L tends to dot BL and L tends to dot D. Now this is called as augmented grammar. Now I name this item set as item set 0. Now, when we talk about this, the next step is we have to process all these dots in all the productions till we bring it at the end. So, till we have to bring this dot to the end, we have to continuously process this. Now, you take up items at 0 and you see a dot is before S, isn't it? So, now which is the item set? It is called as I0. Now, dot is before S. So, you just construct goto of I0, goto of Y0, comma S. Okay. Now, what is meant by goto symbol? Just place this dot one step on the right. Place this dot one step on the right. Okay. That is called as goto. Now, when you just do that, so it will become S dash tends to S dot. S dash tends to S dot. Now, this is a new item set, so I just name this item set as item set 1. Now, come again. Now, in item set 0, you can see a dot is before L also. So, we have to process that also. So, now, in item set 0, go to of I0, comma L. So that's what the step number 2 says. Here, go to of I0, comma L. Just place this dot one step on the right. One step on the right means then it will become S tends to L dot A. So that's what I'm getting here. So S tends to L dot A. The dot is before a terminal, so simply we can ignore that. Now name this item set as item set 2. Now come to the third production. So third production, you can see that in I0, L tends to dot BL. Now we have to process this B also. Now go to of I0, comma B. Go to of I0, comma B. What happens here is we actually try to make L. When we place one step on the right, it will become, when we place this dot one step on the right, it will become B dot L. Now B dot L has been here. But the problem here is a dot is before a non-terminal called as L. When a dot is before a non-terminal called as L, we have to find the closure operation. That means we have to introduce all the productions of L. Now, that's what the next step says. So, introduce all the productions of L. L have two productions, that is L tends to dot BL and L tends to dot D. In SLR parsing, whenever we construct this canonical LR items, we have to place dot before every production. Now, the final step in I0, the final production is L tends to dot D. So we have to process this D also. Now go to of I0, comma D. Go to of I0 comma D actually produces, when you one step place dot one step on the right, it will become L tends to D dot, and that item set has to be named as I4. Now we have processed all the dots in item set 0, spanning from dot before S, dot before L, dot before B and D. We have done it. Now we have to see for other item sets whether dot is before a terminal or non-terminal. Now when we come to item set 1, item set 0 has been completely processed. In item set 1, we can see that the dot is at the end. So when dot is at the end, there is no need to process it. We can stop it. Okay. So in item set 1, there is not any dot before a non-terminal or a terminal. So no need to process it. Now when come to item set 2, we can see a dot before A. Okay, a dot before A. So what we have to do is we have to process this dot before A. So we will write go to of item set 2 comma A. So when we place this dot one step on the right, it will become LA dot. Okay. So go to of item set 2 comma A. 2 comma A. Now it has been written as S tends to LA dot. Okay. Now name this item set as item set 5, because this item set does not exist. LA dot does not exist. Okay. Now we will again go for item set 2 here. We will check it out whether there is any item sets where dot is before any terminal or non-terminal. So only one item set is there. Now when you come to item set 3, you can see a dot before L. So we have to see process this go to of I3 comma L. So it will become BL dot, isn't it? So we will go for go to of I3 comma L. So it has become as BL dot. So since this is a new item set, new production, we will write it as item set 6. So now again go to I3 here. Okay, go to of I3. In I3 you can see that a dot is before B. Dot is before B. Okay. Now we have to process this. When we process this, what will happen? It will become, we'll place this dot in between B and L. So it will become L tends to B dot L. So now what happens is B dot L, since dot is before L, once again we have to find the closure operation of L. So L production will be introduced, L tends to dot BL will be there, L tends to dot D again. We will get the same production called as I3. So the production I3 set has been already repeating now. It is repeating now. So now when we just make go to of I3 comma B, when I do that, I am getting the same item set called as I3. So no need to write second time all these item sets, because already it has been mentioned that it has been named there. So no need to do that. Now when we come for I3, we will just process this D also. Okay, I3, a dot is before D. So what will happen is when we try to process it, when we place this dot on the right side, it will become LD dot. Okay, but check it out whether LD dot exists in other item sets. Yes, it exists in LD dot exists in item set 4. So we will name, when we just process go to of item set 3 comma D, we will again get I4, isn't it? So we will again get item set 4. So go to of I3 comma D, I get an item set called as 4. Okay. Now all this I3 has been processed now completely. You will go for I4. When you go for I4, you can see that no need to process this production because dot is at the end. We can skip it off. Now when we go for item set 5, again a dot is at the end. No need to process this. And when we go for item set 6, dot is at the end. No need to process this. So that's all. We span, we have item set 0 to item set 6. So that's what it has been done. Okay. So we have a canonical item sets from item set 0 to item set 6. Now during the intervening time, we will try to find the first and follow for S and L, because we have two non-terminals S and L. When we just take up this productions S and L, we'll just go for this one. S tends to LA. Okay. So first of S, you go on the right side, you have L. L is a non-terminal first of L. when we take first of L, we have B and we have D. First of L, we have B and D. Okay. So BD is an answer for first of S. And again, when we find first of L, we will get the same answer for L also, B and D. Okay. Now, when we take follow, since S is a starting symbol, we will get dollar. We don't have S on the right side, so dollar is the only answer. So that's what has been mentioned here. When we talk about first of S and first of L, B and D are getting, and follow of S, we have dollar. And follow of L. So how to take this follow of L? So you see L where L is on the right side of the production and apply this alpha, B, beta. Okay. So L is on the right side here. So L is, we take this production, L is on the right side. So when I apply B here, beta will be falling on A here. First of beta is A here. First of A is A. So we will get only answer, that answer. So follow of L is actually A. So we have written this. Now what you have to do is we have to construct the parsing table. So how to construct the parsing table? So before going for this parsing table construction, we will just see here how to define a parsing table or mention a parsing table. So how many canonical items we have? We have items at 0 to items at 6. So simply I am writing in all rows from spanning from 0 to 6 I am writing, because we have altogether 7 item sets spanning from I0 to I6. So we have mentioned that. Next is we have to write all the terminals which pertains to the grammar. So what are the terminals which pertains to the grammar? So we have A terminal, we have B, we have D, and dollar is another terminal which actually is called as follow. Okay. So we have to introduce dollar also, which does not fall under the production. Since follow we have a dollar as a terminal, we have to include that. So A, B, D and dollar are called as terminals, and put together all these terminals are mentioned as action. And now we have another column called as go to. So where there we have to include only the non-terminals. So we have two non-terminals, S and L. So I am writing S and L. Now how to fill these columns? Okay. So the question is how to fill these columns. So the first step what we have to do here is we have to process all the dot before terminals in all item sets. Process all the dot before terminals in all item sets. Now how to do that? Now when we talk about in items at 0, we have to process only the terminals now. Okay. The first step is we have to process only the terminals. In items at 0, we can see a terminal. A dot is before a terminal called as B and dot is before a terminal called as D. So we have to check it out. Go to of items at 0 comma B and 0 comma D. So what it is generating? So now go to of I0 comma B generates me I3. Okay. And go to of I0 comma D generates me I4. Okay. So B generates I3 and D generates I4. Okay. Okay. So now what we have to do here is 0 comma B generates I3 and D generates I4. Okay. So in 0 items at 0, 0 comma B generates I3. So since this is a terminal, I write it as S3, I3. And 0 comma D, go to of 0 comma D actually generates I4. Okay. So I simply write it as S4. S4 or S3 is called as shift 3 and shift 4. So all the terminals has to be mentioned like this. Now in items at 0, we have dots before only B and D. Now come to items at 1. Items at 1, we don't have a dot before terminal. Okay. So no need to process that. Now come to items at 2. We have a dot before A. Okay. So in item set 2, a dot before A. So go to of item set 2 comma A, where it goes. Go to of item set 2 comma A, produces me I5. So 2 comma A, so in 2 comma A, it produces I5. So I write it as S5. Shift 5. Now, come to item set uh, 3. Go to of item set 3. So in item set 3, we can see a dot before B and D. Okay, a dot before two terminals B and D. Okay, second protection, third protection. So go to of I3 comma B, I3 comma D. We have to see that. So go to of I3 comma B. So go to of I3 comma B produces I3, and go to of I3 comma D produces I4. Okay, go to of I3 comma B produces I3. Okay, so in 3I3, go to of I3 comma B produces I3, isn't it? So 3 in B, it produces I3, so write it as S3. Go to of I3 comma D produces S4, isn't it? I4, so write it as S4. This columns. Now we will go for item set 4. So in item set 4, there is not a dot before a terminal, and in item set 5 not a dot before a terminal, and item set 6 also we don't have a dot before terminal. Okay, so since rule number 1 has been satisfied, we have processed all dots before terminals. Okay, now we will check it out a dot before non-terminals. Okay, so because now rule number 2 says process all dot before all non-terminals in all item sets. Now once again you come for item set 0. See a dot before a non-terminal called as S. So, okay, it is available in item set 0, isn't it? So go to of item set 0 comma S. Okay, so go to of item set 0 comma S produces me I1. Okay, then we have another dot before a non-terminal called as L. So go to of item set 0 comma L. Okay, now where it goes, go to of item set 0 comma L produces I2. Okay, since these are non-terminals, it happens in item set 0. So when you come to the table, so 0 comma S, go to of I0 comma S produces I1, isn't it? So I write it as 1, simply write it as 1. If it is I1, write it as 1. Now go to of 0 comma L produces I2, isn't it? So I simply write it as 2. I2 means it is 2. Okay. Now we have processed all the dots before all non-terminals in item set 0. So come to item set 1. In item set 1, we don't have a dot before a non-terminal. We will simply skip it off. Now, in item set 2, we don't have a dot before non-terminal. So we can skip that also. Now, in item set 3, we have a dot before non-terminal called as L. Okay. So go to of I3 comma L. So go to of I3 comma L. Go to of I3 comma L produces me I6. So go to of I3 comma L. So in 3 and L is here. Okay, it produces I6 here. So I simply write it as 6. I6 has to be written as 6 here. Now we'll go for I4. I4 there is not dot before in a non-terminal, and I5 we don't have a dot before non-terminal, and I6 also we don't have a dot before non-terminal. Okay, so rule number 2 has been completed. Now come to rule number 3. So rule number 3 is process all dot at the end of production. So how to process that? Now spanning from item set 0. In item set 0, we don't see a dot at the end of the production. Simply we skip it off. Now when you go to item set 1, you can see a dot at the end here. S dash tends to S dot. Okay. So now this is item set 1. Since this is an augmented production, isn't it? It's not original production, it's an augmented production. So we have actually, it's a processed production. After we take the grammar, we have processed this and introduced this new production. So in item set 1, when you make S dot, Okay, S dot means in item set 1, see where is dollar in item set 1, because S dash tends to S dot actually takes place in item set 1. Okay, so in item set 1 where dollar is there, so simply make it as accept, simply make it as ACC. ACC is called as accept here. Okay, now we will go and see item set 2. In item set 2, a dot is not at the end. Okay, in item set 3, dot is not at the end. In item set 4, we have L tends to D dot. Okay, now here comes the issue. When you have L tends to D dot, we have to see what is follow of L. Now follow of L is A. At the same time, we have to see what is this production. Okay, now I'll just name the production. S tends to LA is production number 1. Okay, and second production is L tends to BL is production number 2, and production number 3 is L tends to D is called as production number 3. Now what we have to do in this case? Okay. Now see here where dot is available. In I4 we have L tends to D dot. Okay, so if dot is available at the end, you find the follow for L. So follow for L is actually A. And what is this original production? L tends to D dot. Okay, it comes from L tends to D, isn't it? L tends to D dot comes from L tends to D. So see the production number for L tends to D. It is 3. It is production number 3. So in I4 we get L tends to D dot, and see what is actually the follow for L. Follow for L is actually A. So in I4, and production number it is 3, isn't it? In I4 where A is there, okay, where A is there, this is the place where A is there. Okay, here you have to write it as R3 because it is production number 3. L tends to D is called as production number 3, so I write it as R3. R3 is called as reduce 3 or reduction. Okay, now we'll go for the next one. Okay, in I4 and I5 we have S tends to LA where dot is at the end. Now you have to see what is the follow for S. Okay, and LA dot, S tends to LA dot comes from S tends to LA, isn't it? Okay, it comes from production number 1. So we have to see follow for S in item set 5. Follow for S is actually dollar. Now in item set 5 in dollar. Okay, so this is production number 1, isn't it? Okay, production number 1, so write it as in dollar, production number. I5 dollar, write it as production number 1 because dollar is called as a follow, so that's why I'm writing it as R1 here. Now come to the last production. Okay, now the last production is L tends to BL dot. Now this is item set 6. In item set 6, L tends to BL dot. BL dot comes from L tends to BL, which belongs to a second production. So now we have to find the follow for L. Follow for L is actually A. Okay, so in item set 6, this happens in item set 6, isn't it? Okay, we have this production in item set 6. In item set 6 where A is there, since this is production number 2, so write it as R2. Okay, so this is the way of filling the parsing table. Now the next step is we have to take a valid string. So how to actually we take a valid string? So we can say that S is called as a starting symbol, and the starting symbol S can be replaced by LA. So I introduce a production called as LA here. Now when we talk about LA, this L can also be replaced by a production called as L tends to BL. Another production is there. Okay, so I introduce this production. Okay, L tends to BL. So I substitute this L by BL. So this L is substituted by BL. Okay, so now the string will become BLA. Now I can also replace this L by D, isn't it? So see the production number 3. L can be replaced by D here. Okay, so L can be replaced by D, and finally I get a string. Now you can see that all the elements here are actually terminal. So BDA is called as a valid string for this corresponding SLR parsing. Okay, now we have to parse this string. So how to parse this string? So now we go here. I just go here. Adjustments. Okay. Now we take input string called as B, D, and A dollar. Okay. So BDA dollar is called as the end of the string. BDA is called as a valid string now. So I start with stack symbol. Okay. Now you have to stack from item set 0 because that is the first item set. We start from 0. So 0 and BDA. Okay. 0 and B. Okay. In the left side you have 0 and the right side you have B. Now you go and check with the parsing table. So what is the entry there? So 0 and B, we have S3. S3 means it's called a shift 3. Okay. Now, in action, you write it as S3. Okay. Now, what we have to do when the case is actually S3, shift 3. Now, when the operation is actually shift 3 or a shift, okay, we have to push one element from the input to the stack, and then we have to push the corresponding shift number inside the stack. Okay. Now, so we have to push one element from the stack. One element means the first element. So B is the first element. So now 0 will become 0B. Okay. And after that, we have to push that number. So what is the number here? Shift number is 3. So I write it as 3. Okay. Now what will be remaining in the input? We have inputs called as D, A, dollar. Okay. Now see here. 3 is on the left side and D is on the right side. 3 is on the left side and D is on the right side. Okay. Now go to the table and check it out, 3 and D. So 3 is here and D is here. Okay. 3 and D actually takes an action called as S4. So 3 and D is actually S4. Is actually S4. That is again a shift 4. So shift 4 means what you have to do? We have to push one element inside the stack and the corresponding shift number. So it will become 0, B, 3, and we push this D inside, D will be there, and push this shift number. Shift number is 4 now. 4. So what will be remaining? A dollar. Okay. Now you see on the left side you have 4, on the right side you have A. Now check it out. This rule 4 comma A. So 4 and A we have R3. R3 means production number 3. Okay. R3 means reduce operation. 4 comma A gives me R3. So R3. So what is production number 3? So I write it as R3. R3 is actually L tends to D. This is called as production number. Okay. L tends to D is called as production. Now, when we have a reduce operation, what we have to do? We have to take the right side of the production. How many elements are there in the right side of the production? We have only one element called as D. Okay, if that is the case, then pop two elements from the stack. If you have one element on the right side, pop two elements. If you have two elements on the right side, pop four elements. If you have three elements on the right side, pop six elements from the stack. Okay, so now I am just popping two elements. I have one element on the right side of this production. So I pop two elements. So what are the two elements will be going off? 4 goes off and D goes off. Okay, so what will be remaining? So we have 0, B and 3. Okay, we have 0, B and 3 will be remaining. Okay, now what is the next step we have to do? Now we have to push the left side non-terminal inside the stack. So in this production, what is the left side non-terminal? L is the production. Okay, it's actually L production. L is called as a non-terminal. So this left side non-terminal has to be pushed inside the stack. So now I push this inside the stack. Now you have to see inside the parsing table where left side you have 3, right side you have L, isn't it? So 3 and L. Okay. Now see in the parsing table, 3 and L. 3 is here, 3 and L. Okay. 3 and L meets in 6. Okay. Now write that 6 inside the stack. Now what is there in the stack now? Input now, $A is the input. Now 6 and A. Now see here, 6 and A. 6 and A where meets? Where it meets. Okay. Now 6 and A, 6 and A meets with R2, isn't it? Okay. 6 and A meets with R2. 6 and A meets with R2. So I'll write it as R2 here. So 6 and A meets with R2. So write R2. And what is production number? What is the production? L tends to BL is called as a production, isn't it? L tends to BL is called as R2 production. Now see here, we have two products, two elements on the right side. Okay, that means we have to pop 4 elements from the stack. So we will pop 4 elements from the stack. What are the 4 elements? 6 goes off, L goes off, 3 goes off, and B goes off. So what will be remaining? Only 0 will be remaining. So 0 will be remaining. Okay. Now then push the left side non-terminal on the stack. So left side non-terminal is L. So L should be pushed inside the stack. So L should be pushed inside the stack. Now you see 0 and L. Now you see 0 and L. Okay. So 0 and L meets with 2. Okay. 0 and L meets with 2. Okay. So you write 2 inside the stack. You write 2 inside the stack. Now what is remaining here? A and dollar is remaining. A and dollar is remaining. Okay. Now listen carefully. Now 2 and A. Now see here, left side you have 2, right side you have A. Okay. Now see in the production, so in the parsing table, 2 and A. Okay. So 2 and A. So 2 and A meets with so 2 and A. So 2 and A meets with SY, isn't it? It is SY. So now I have to go here and write it as S5. S5 means shift 5. Okay. Shift means what you have to do? You have to push this element inside the stack. When you push element inside the stack, this will become 0, L, 2, A, and then push that number also. Number is 5. 5, and what will be remaining? Dollar will be remaining. Now see 5 and dollar. 5 and dollar in the table. Okay. So when you see 5 and dollar, you see 5 and dollar. 5 and dollar is okay. 5 and dollar is R1, isn't it? 5 is here and dollar is here. It meets with R1. Okay. So now we write it as R1. R1. Okay. What is R1 production? S tends to LA is called as R1 production. S tends to LA is called as R1 production. Now, when you just see this, we have 2 elements on the right side. So that means pop 4 elements from the stack. It's a reduced production, isn't it? 4 elements means what will done? 5, A, 2 and L goes off. So 0 will be remaining. 0 will be remaining. Now push the left side non-terminal inside the stack. So S is the left side non-terminal. So I push 0 and S. Now see here, left side you have 0, right side you have S. Now go to the table and see 0 and S. So 0 and S here. So we have 0 and S. So 0 and S, 0 and S meets in 1, isn't it? So I write it as 1. 0 and S meets in 1. So I write it as 1 here. Okay. Now on the right side you have dollar symbol. Now see, left side you have 1 and right side you have dollar. Okay. Now simply see in the table. So see in the table 1 comma dollar. Okay. Now see here 1 and dollar. Okay, 1 and dollar, you check with the table. Now 1 and dollar is accepted, isn't it? So 1 and dollar, it ends here. So I simply write it as accepted. Accepted. So that's it. Finally, you have to get this state. Then whatever you have done is right, including the parsing table and the string, whichever you have taken is right. Okay, so that's about SLR parsing. Thanks for watching the video. Have a good day.